Hello guys, I'm a teacher Limbokan Sejuko Masame. Let us consider the question below and try to see how we can find the answer for this question. We ask you to find the distance of each center of gravity from the seeker end. This is a cylindrical steel shaft that is turned down on the lathe in such a way that its radius is reduced to half of its origin. And this cylindrical steel shaft has a distance, a length of 50 centimeter. Then this lathe is molding this radius up to distance of 20 centimeter for a radius of 1 centimeter. Consider this a cross-sectional line that drawn the center of the along the center of the cylindrical steel shaft. We know this is its original center of gravity. After molding this is cylindrical steel shaft, we will have a thin part and thick part. We will have a center of gravity for thin part, and we will have center of gravity for thick part. And we must know that because from here a distance for a thin part is 20, then the half distance is 10 centimeter, and for thick part distance is 30, then the half distance is 15 centimeter. Then the distance between a center of gravity for thin part and that of thick part is equal to 25 centimeter in sum. Then we assume that the new center of gravity will lie between the original center of gravity before molded down to a thin part and thick part to the thick center of gravity. Then we take these positions as a new center of gravity as C dot G dash. Then the distance from center of gravity for thicker to the center of gravity, new center of gravity, is assigned as x. Then the remaining distance from the thin center of gravity to the new one is 25 centimeter minus x. And when we consider this definition for this abbreviations, then you can pass through it. Let us assume that we take a moment about the new center of gravity. Then we put the fulcrum here. Then we'll have a clockwise moment and anti-clockwise moment. Later, and we assign L1 for a half distance for thin end and L2 for half distance for thick end. Then from principle of moment, sum of clockwise moment is equal to sum of anti-clockwise moment. Then W2 for thicker end times a distance, perpendicular distance x is equal to W1 for thinner end times perpendicular distance is 25 centimeter minus x. Okay, then we define W as mass times the acceleration due to gravity. Then we multiply with the respective perpendicular distance. Then we define mass for each side. The mass is equal to volume times density. Remember that this is still cylindrical shaft, hence the density are common because the shaft is of the same nature of the steel. Then we cancel each other. Now these volumes, we assume that we take this half volume for each thinner and thicker end. Then we take this L2 as half of the whole distance for thinner and for whole distance for thicker. Then we make the subject distance x. Then distance x will remain as 25 centimeter. R small r square L1 and capital R square L2 plus small r square times L1. At the end, we will have the answer for x, which is 3.6 approximately. Then the distance of its center of gravity, a new center of gravity from thicker end, as you can see here, is equal to x plus 15 centimeter. Then our distance is equal to 18.60 centimeter approximately. Remember that by assuming taking the half the distance for thinner and thicker, the answer will be the same even if we will take the full distance for a volume. For a volume, if we took a full distance, the the answer will be the same as when we take the half distance, because the factor of 2 here will cancel each other. Okay, thank you for watching. Please like and share, comments, don't forget to subscribe for more videos like this one. Thank you guys.